Hello viewers, in this lecture we are going to solve some problems on definite integrals. Viewers, in my previous video we have discussed how to evaluate the definite integrals by using this formula, that is FB minus FA. Here also we will make use of this formula, but before applying this formula we will try to simplify this integral by using substitution method. One more thing which we are going to study is that we will also see, or will also study how to change these limits, right? So let us solve this integral with the help of substitution method. Now let us call this integral I. Now here we see that we have sin x over 1 plus cos square x. Now suppose we put say t is equal to cos x, then we have dt is equal to minus sin x dx, right? So minus dt is equal to sin x dx. So it means for sin x dx we can write minus dt. Clear? So the purpose of using a substitution method is to change this integral which is given in the variable x to variable t, and while doing so we have to change the limits also, right? Okay, so we have sin x dx is equal to minus dt. So here we have minus dt, and in the denominator we have 1 plus cos square x, and for cos x we'll have t square, right? Now here we cannot once we have changed this integral from variable x to variable t, now we cannot write these limits. Okay, so we'll change the limits accordingly. So the method is, here we have t is equal to cos x, and here we have the limits x is equal to 0 to x is equal to pi by 2. So when x is equal to 0, t is cos of 0, right? Because t is equal to cosine of x. So when the lower limit is 0, then we have x equal to 0, so t equal to cos of 0, which is equal to 1. And when x is equal to pi by 2, so t is equal to cos of pi by 2, that is equal to 0, right? So the limit is now changed from 0 to pi by 2 to 1 to 0, right? So here we'll write 1, and here we'll write 0. Okay, now this can be written as 1 to 0. We'll take negative sign outside from this integral, so we have dt over 1 plus t square. Now the integral of 1 over 1 plus t square is nothing but tan inverse of t, and here we have 1 to 0, right? Now we'll apply this rule here, and we have tan inverse of 0 minus, first of all we'll find the value of tan inverse t at t equal to 0, then we have minus, and then we'll take the value of tan inverse t at t equal to 1, right? So here we have tan inverse of 0 is 0, tan inverse of 1 is pi by 2, it is pi by 4, and now minus and minus is plus, so we have pi by 4. So here's the value of this integral is pi by 4. Now viewers, let us find the value of this definite integral by using substitution method and by changing the limits. Clear? So here we have the limits from x equal to 0 to x equal to 2 because this integral is given in the variable x. Now let us substitute, put as t is equal to x plus square root of x plus 5, right? So it means we have t square is equal to x plus 5 and x is equal to t square minus 5. So we have t square equal to x plus 5. So we have when we differentiate both sides, we have 2t dt is equal to dx. Okay. Now for changing the limits, when we have x equal to 0, then t square is equal to, because here we'll substitute x equal to 0, so we have t square is equal to 0 plus 5, that is 5. So t is square root of 5. And when x is equal to 2, we have t square is equal to 2 plus 5. Here we'll substitute x equal to 2, so we have 7, and we have t is equal to square root of 7, right? So here's this integral becomes, for x equal to 0 we have t is equal to square root of 5, and for x equal to 2 we have t equal to square root of 7, and for x we have t square minus 5, and for square root of x plus 5 we have t, and for dx we have 2 t dt, right? So here's this can be simplified as taking 2 outside this integral sign. We have the integral from square root of 5 to square root of 7, and we have t square. So if we multiply it with t square minus 5, we have t4 minus 5t square, right? Okay. Now now the integral of here we have 2. The integral of t raised to 4 is t5 over 5, and minus here we have 5. The integral of t square is t cube over 3, and we have from square root of 5 to square root of 7, right? Now if we take the LCM, here we have 3t5 minus 25 and t cube over 15, right, from square root of 5 to square root of 7. So we can write 2 over 15. Now first we'll substitute square root of 7 here. So we have 3 times of 7 raised to 5 by 2, and then we have minus, then we have 25 times 7 raised to 3 by 2. Clear? Okay. Now we have minus sign, then we'll substitute square root of 5 here. So we have 3 times, this is 5 raised to 5 by 2, and minus we have 25 times, here we'll substitute root 5, so we have 5 raised to 3 by 2, right? Okay. Now so this is the required value of this integral. Clear? We can also simplify this further, but Okay, leave it as such. So this is the required integral of value of this integral. Viewers, let us take this problem. Here we have to find the definite integral from 0 to 1 tan inverse x divided by 1 plus x square. Now here we see that that if we take say t is equal to tan inverse x, then we see that dt over dx, that is the derivative of tan inverse x with respect to x, is 1 over 1 plus x square. So dt is equal to dx over 1 plus x square, right? So for this part we have dt, right? And for tan inverse x we have t. Now here we have from x equal to 0 to x equal to 1. So let us change the limits also. So when x is equal to 0, so t is tan inverse of 0. So tan inverse of 0 is 0, and when x is 1, we have t is equal to tan inverse of pi by, it is 1. This is 1, and tan inverse of 1 is pi by 4, right? So this integral becomes from 0 to 1. The limit is from 0 to 1, so the limit now becomes 0 to pi by 4. For tan inverse x we have t, and for dx over 1 plus x square we have dt, right? So now this is quite easy. The integral of t is t square over 2, and we have the limit 0 to pi by 4. Now we have to find here fb minus fa. So this is a, this is b, and this is f of x, that is f of t. So this is pi by 4 square divided by 2 minus 0 square divided by 2. So this is pi square over 16 divided by 2. This is 0, so we have pi square over 32, right? So pi square by 32 is the value of this integral. Now let us take this problem. Here we have to find this definite integral from 0 to 1 x e raised to x square. Now here we are put x square is equal to t. So dt is equal to we have 2x dx, because we can write dt over dx as 2x, right? So dt is 2x dx, so x dx can be written as dt divided by 2, right? So here's let us change the limits. So when this is x equal to 0, here we have x equal to 1. So when x equal to 0 here, so t is 0 square, that is 0, and when x is 1, t is 1 square, right? So 1 square is 1. So when x changes or x varies from 0 to 1, so t also varies from 0 to 1. So the limits changes to 0 to 1, and for x dx, we have half dt here, and for e raised to x square we have e raised to t, right? So we can write it as half 0 to 1 e raised to t dt. Now the integral of e raised to t is e raised to t, we have 0 to 1, so this is half, we have e raised to 1 minus e raised to 0, so where's this is half. For e raised to 1 we have e, and for e raised to 0 we have 1. So this is the required value of this integral. Now viewers, let us take this problem. Here we have to find the integral of square root of sine phi cos 5 phi from the limits 0 to pi by 2. So here we'll solve this definite integral by the method of substitution, and we'll also change the limits. So let say t is equal to sine phi, right? So dt is equal to cos phi d phi. So here we have substituted t is equal to sine phi. So dt over d phi is cos phi d phi, right? Now when this is phi, so when phi is 0, so t is equal to sine 0, right? And sine 0 is 0. And when phi is pi by 2, then we'll have t is equal to sine pi by 2, that is 1. So when the limit goes from 0 to pi by 2, then the value of this t parameter will change from 0 to 1. So here we'll have 0 to 1, and now here we'll have for sine phi we have t, and now let us simplify, or let us rearrange this term. Cos phi, this is raised to power 5. So here's, if we write this as cos 4 phi times cos phi d phi, then for this cos phi d phi we will have dt, right? So here we'll write dt. So we can write 0 to 1, this is square root of t, and here we'll have dt. Now for cos raised to 4 phi, this can be written as cos 4 phi can be written as cos square phi square, then cos square phi is 1 minus sine square phi, and this is square. And for sine phi we can write t. So this is 1 minus t square raised to power 2. So here we'll have 1 minus t square whole square. Now we have to simplify this expression. So this is 0 to 1. Here we have t raised to half, and 1 minus t square whole square is 1 plus t4 minus 2t square, right? Now if we multiply this term with t raised to 1 by 2, then we'll have t half plus t 9 by 2 minus 2 t, and this is 5 by 2, right? And dt. Now we'll integrate this expression term by term. So here we can write t raised to half. When we integrate it, we'll have 3 by 2 over 3 by 2, and then we have t raised to 9 by 2 is 11 by 2 divided by 11 by 2, and then we have 2 times of t raised to 5 by 2, that is 7 by 2, and here also we have 7 by 2, and the limits are from 0 to 1, right? Okay, so viewers, now we'll substitute the value of 1 here. So we can write as 2 by 3 t raised to 3 by 2 plus 2 by 11, this is t 11 by 2, and then we have 4 by 7 and t raised to 7 by 2, and the limits are from 0 to 1. Now we'll substitute t is equal to 1, and then we have 2 raised 2 by 3, and this is 1 raised to 3 by 2 plus 2 by 11, and then we have 1 raised to 11 by 2. Here we have 4 by 7 and 1 raised to 11 by 2, and minus, and if we substitute 0 here, then the all the three terms will become 0, so here we will have 0. So this is 2 by 3, because 1 raised to 3 by 2 is 1, 1 raised to 11 by 2 is 1, and 1 raised to, this is 7 by 2. This is 7 by 2. So this is also 1. So we have 2 by 3 plus 2 by 11 minus 4 by 7. Now viewers, if we take the LCM of 3, 11 and 7, we have 231, and in the numerator we'll have these three terms, and if we solve this numerator, we'll get 64 and divided by 231. So the value of this integral, definite integral, is 64 divided by 231, right? Now viewers, let us take this problem. Here we have to integrate 1 over x square plus 2x plus 5 from -1 to 1, right? So here we see that the denominator is of the form ax square plus bx plus c, and in the indefinite integrals we have seen that whenever we have an expression, a quadratic expression in the denominator, then we convert it into a complete square, right? So what we will do here, so we'll write this expression x square plus 2x plus 5 as x plus 1 whole square plus 4, right? Okay, now let us put t is equal to x plus 1. So dt is equal to dx, and the limits will be changed, and when x is equal to -1, then t is -1 plus 1, that is 0, and when x is equal to 1, then t is 1 plus 1, that is 2. So when x changes from -1 to 1, then t varies from 0 to 2, right? So here's this becomes 0 to 2, and for dx we have dt, and for x plus 1 we have t, so this is t square plus 4, right? This can be written as 0 to 2, this is dt, we have t square plus 2 square, and now we know that dx over x square plus a square is equal to 1 over a tan inverse x over a. So this can be written as 1 over 2, this is tan inverse t by 2, and here we have 0 to 2. Now we'll substitute the value of 2 here. So we have half tan inverse 2 over 2 is 1, then we have t equal to 0 here, so we have tan inverse of 0. So this is half, tan inverse of 1 is pi by 4, tan inverse of 0 is 0, so we have pi over 8, right? 1 by 2 times pi by 4 is pi by 8. So this is the required value of this integral. Now viewers, let us take this problem. Here we have to integrate 1 over 4 plus 9x square, and the lower limit is 0 and the upper limit is 2 by 3. So here x varies from 0 to 2 by 3. Now this integral can be written as 0 to 2 by 3, here we have dx, and if we take 9 common, so this is 4 by 9 plus x square, right? So this can be written as 1 over 9. This is from 0 to 2 by 3. This is dx over, this can be expressed as 2 by 3 square plus x square. And and see, this integral is of this type, right? So this is x square here, and for a we have 2 by 3. So this integral can be written as 1 over a. For a we have 2 by 3, then we have tan inverse, here we have x, for a we have 2 by 3, right? And from the limits are from 0 to 2 by 3. Now this is 1 by 9, here we have 3 by 2, and this is tan inverse 3x over 2, and the limits are from 0 to 2 by 3. And now this can be written as 1 by 9 times 3 by 2, and tan inverse, if we substitute the value of x equal to 2 by 3 here, so we have 3 by 2 times 2 by 3, and here minus we have 0, so this is tan inverse of 0, so this is 3 3s are 9, so we have 1 over 6, and here we have tan inverse 2 get cancelled, 3 get cancelled, so we have tan inverse of 1 minus 0. Tan inverse of 0 is 0, so this is 1 by 6, and tan inverse of 1 is pi by 4 minus 0, so this is pi by 24, right? Now let us solve this problem. So here we have to integrate or we have to find the definite integral from 0 to 1 of sine inverse 2x over 1 plus x square. So here also we'll make a substitution, and the proper substitution, or you may say the appropriate substitution, is x is equal to tan theta. So when x is equal to tan theta, then this whole term, that is sine inverse 2x divided by 1 plus x square is equal to sine inverse 2 tan theta over 1 plus tan square theta. So this is sine inverse, and 2 tan theta over 1 plus tan square theta is sine of 2 theta. So sine and sine inverse get cancelled by definition of inverse functions. So we have 2 tan theta, which can be written as 2 times of tan inverse x, right? So here's now what we will do, we'll find dx, and dx over d theta is your sec square theta, so dx is sec square theta d theta, right? And the limits of integration will change to when x is 0, so tan theta is 0, so theta is 0, and when x is equal to 1, then tan theta is equal to 1, so theta is equal to pi by 4. So this integral becomes 0 to pi by 4, and for this term we have 2 theta, right? So we have 2 theta, and for dx we have sec square theta, right? Now this can be written as 2 times of 0 to pi by 4, and we have theta times sec square theta. And now this is the product of two functions, so this will be integrated by making use of parts, and here this will be taken as first function, and sec square theta will be taken as second function. So we'll make use of the method of integration by parts. So let us integrate it. So we have theta and sec square theta. So here's this can be written as the first function is theta. So we have theta, then integral of sec square theta d theta minus, then we have integral sign here, then we have the derivative of theta, then we have integral of sec square theta d theta, and then bracket closed, and here we have the d theta, right? The formula for integration by parts is given as, if u and v are two functions of x, then we have, if u is the first function, then we have u and integral of v, then we have the derivative of u, and then we have integral of v, and then we have dx, right? Okay, so here we have theta, then the integral of sec square theta is tan theta, then we have minus, and here we have integral, then the derivative of theta with respect to theta is 1, the integral of sec square theta is tan theta, right? Now we have theta tan theta, and then the integral of tan theta, we know that it is minus of cos theta, so we have minus and minus of it is log of minus of log of cos theta, right? So this is theta tan theta, and this is plus log cosine of theta, right? Now viewers, now the indefinite integral of theta sec square theta is theta tan theta plus log of cosine of theta. So we have to find the definite integral. So we'll substitute the limits here, that is 0 to pi by 4. So when we substitute pi by 4 here, so we have pi by 4, this is tan pi by 4 plus log of cosine of pi by 4, and then we have minus, and if we substitute the value of theta is equal to 0 here, so we have 0, and then we have a log of cosine of 0, right? So this is pi by 4, tan pi by 4 is 1, so we have pi by 4 times 1 is pi by 4, plus this is log of cosine of pi by 4 is 1 over square root of 2, right? And this term is 0, cos 0 is 1, so log of cos 0 is log of 1, that is 0, right? So we'll this term, this entire term will become 0, so we have pi by 4 plus log 1 by square root of 2. Now we have a factor of 2 outside this integral when we have made the substitution as x equal to tan theta. So therefore I is 2 times of this factor, right? This is pi by 4 plus log of 1 by square root of 2, so this is I is equal to pi by 2 plus 2 log 1 by square root of 2. So this can further be written as minus of log of 2, because log of 1 over square root of 2 can be written as log 2 raised to minus half, which can be written as minus half log 2, and this 2 and this 2 get cancelled. So we have the final answer as pi by 2 minus log 2.